Now coming to the next question. The letters of the word article. The letters of the word article. Please read that question carefully. Nowadays, the students are avoiding the habit of going through the question and understanding it because the patience levels are nowadays gone down to the students. So first of all, go through the problem, read it carefully and understand the given concept there, and try to apply what we have learned now. So the letters of the word article are taken 4 at a time and arranged in all possible ways. Find the number of arrangements containing R and not containing E. So, what are the letters here? A, R, T, I, C, L, E. Now what we need? We need 4 letter arrangements. Then you may think that, sir, here the question, we have to write the number of arrangements. So arrangements are nothing but permutations. So now we have to apply the permutation formula. Of course, the permutation formula itself is derived from the principle of counting. We can do that using principle of counting also. So what you have to do first of all, you have to fulfill the restriction given. What is the restriction given there? It must contain R and it should not contain E. That means E to be avoided. We are avoiding E now, and R must be there. R must be there. So you have to take this R, and R should be placed either here or here or here or here. So R can be placed in how many different ways? 4 different ways. R is placed now. It's common sense. Sir, without repetition or with repetition? No question at all, because each single letters. You have to take from this only. No question of repetition in this case now. So R can be placed in 4 different ways. That means R may be present anywhere in these 4 blank places. R will be occupying one place. R will be occupying one place. And how many places are remaining? 1, 2, 3. How many letters are remaining? E removed because we don't want. And R already placed. How many places remaining? 3 places. How many alphabets remaining? 1, 2, 3, 4, 5. 5 alphabets are remaining. So first operation is done. What is the first operation? Filling R in any one of the 4 blank places, which can be done in 4 different ways. It's done. Now what about the remaining? A, T, I, C, L. So how many letters are there? 1, 2, 3, 4, 5 are there. So this can be filled in how many different ways? 5 different ways. And this can be filled in how many different ways? 4 different ways. And this can be filled in how many different ways? 3 different ways. Understand it? So what is happening here? We are fulfilling the restriction first, and then we are filling the remaining places. So first operation of filling up of R is done in 4 different ways. Because E is not needed, E removed, and remaining letters 5 are there. This is filled in 5 different ways, and this is filled in 4 different ways because already 1 is filled, and 4 filled, and already 2 are filled, only 3 are remaining. This can be done in 3 different ways. First operation, second operation, third operation. All these operations, one after the other or simultaneously, can be performed in 4 into 5 into 4 into 3 different ways. It is 20 into 12, which is nothing but 240. 240 different ways we can have the 4 letter arrangements that contain R, not containing E. Understand that. So this type of questions also you can answer very easily. Okay. Next, find the sum of the numbers formed by taking all the digits from 1, 3, 5, 7, 9. And you have to go through the question carefully, which is very important and also little tricky. Why you may be attempting such problems. Find the number of numbers that can be formed. It is not find the number of numbers. You have to see that it is a find the sum of the numbers. Sum of the numbers means what? I'll take an example and I'll explain you. Like I have 1, 2, 3 in my hand. I want to form different three distant numbers without repetition. Then in this case it is 1 2 3, 1 3 2, 2 1 3, 2 3 1, 3 1 2, 3 2 1. Then you are written this, then what is the use of principle of counting? You may be thinking like that, isn't it? Good. Then in such a case, because a three distant number contains three places, I am choosing three places here, and first blank place can be filled with either of these three in three different ways, because without repetition we need it. So we can fill this in two different ways because one digit is already filled. And this can be filled in one different way. So it is 3 into 2 into 1, which is nothing but 6. These 6 are shown to you clearly. You have written them. So here in this case, what happens? You have to understand, you have to find the sum of all this. According to that question, of course, that's a 4-digited. By taking all the digits means it is a 5-digited number. It's a 5-digit number, but for your understanding, I have taken only 3-digit number. You have to find the sum of all this. So from this one, what I want to make you understand, in this case, 1 is in 1's place. The sum contributed by 1 is 1 into 1. In this also 1 into 1. And sum contributed by 2 in this case is 2 into 1. In this case also 2 into 1. The sum contributed by 3 in this case is nothing but 3 into 1. And in this case also it is 3 into 1. So that means if you split the place wise to form the number 123, it should be 1 into 100 plus 2 into 10 plus 3 into 1 will give you 123. Understand that. The number 123 is formed with the contribution of 1, 2, 3 and by placing them in hundreds, tens and ones place. So you can split this number like it is 2 into 10. It is 1 into 100. That's what I have shown it here. 1 into 100 plus 2 into 10 plus 3 into 1 becomes 123. So what you have to understand here, let us do like this first. Let us add all of this. Let us add this. 4, 3, 7, 6. It is, I think it should be 1331. You can count this. So what we do, this 1 is in 1's place in this case, this 1 is in 10's place in this case, this 1 is in 100's place in this case. So we will split it like this. Sum contributed by 1. Sum contributed by 1 will be like, I will do like this. Because it is a 3-digit number, I will place 1 in 1's place and 1 in 10's place and 1 in 100's place. Now, I need the number of numbers that are containing 1 in 1's place. So, how many digits are remaining here? 2 digits are remaining. So, these 2 digits can be filled in 2 different ways. Here it can be filled in 1 different way. So, it is 2 into 1 and 1 is 1 only. That is, 2 numbers will contain 1 in 1's place. It's clear. This one, 2, 3, 1, 3, 2, 1. 2, 3, 1, 3, 2, 1. We are applying the principle of counting here. Now, what is the sum contributed here? Now, 2 into 1 into 1 into 1 only. Why 1? 1's place, 1. In this case, also 2, this is 1, this is 1. So, this is 2 into 1 into 1 into, this is 10. Similarly, this is also you can say 2, 1, 1. This is also 2 into 1 into 1 into 100. If you add this, this is 2 into 1 into. If you add all this, what will be getting? What will you be getting? It is 111. This is the sum contributed by 1. Similarly, sum contributed by 2 will be. Similarly, sum contributed by 3 will be. If you add all this, then you will be getting, this is 2 into 1 taken common into 111 also taken common into the sum of the days is 1 plus 2 plus 3. Okay, this will give you 1331. Similar manner you can solve this problem also. That means here I have given you an example of 3 distant number. You note down that problem and you split it in this way. Sum contributed by 1, next sum contributed by 3, next sum contributed by 5, next sum contributed by 7, next sum contributed by 9, and add all of them. Then your answer must be like this. Your answer will be 66,66,600. You try that one, and without using the permutations, with the use of principle of counting, I have given you this example. You try that one, and in the next class, we will go to the next slide. In the next class, we will derive NPR. P of n comma r is equal to n factorial upon n minus r factorial, and we will understand how the principle of counting is used to derive that permutation formula n factorial by n minus r factorial, and what is with repetition and what is without repetition, and all this will be made into the formula for our convenience. But the principle of counting is very important for work out or to derive any formula in such a case. Okay, we'll see you in the next class.